Hey guys, in today's video we're going to be looking at matter classification. So we're going to be looking at distinguishing between elements, compounds, and mixtures, and we're going to be looking at the difference between molecules and compounds. We're going to start out with a definition of matter, where matter is our physical material in our universe. So this is going to be anything that has mass and occupies space. So it has volume. So all the physical things in the world. There is a lot of matter, and all of it is going to be some combination of the same 118 elements. Made up of some combination of the 118 elements on the periodic table. So, periodic table, staple in any chemistry classroom. You can find it in your book, or you can just look one up. But we're going to look at that. And then within composition, we could also look at pure substances versus mixtures. So our pure substances are going to be elements or compounds. Where an element means that we have one atom type. So this is what we're actually looking at on the periodic table. With our element, we can either have monoatomic, so single atom, such as neon or carbon or helium, or we can have a molecular element. So these are going to have one atom type, but it's going to be more than one atom bonded together. So two or more of the same atoms bonded together. So we have some diatomics, and these you should commit to memory. Our diatomic elements are elemental forms: H2, N2, O2, F2, Cl2, Br2, and I2. So these 7 diatomic molecular elements you should have memorized. Anytime I say H2, you should know that that's the elemental form of hydrogen, or if I say oxygen gas, you should know that the elemental form of oxygen gas is O2. So commit these to memory. These are important. Pink means important. Okay. And then we also have some polyatomic molecular elements, and that includes stuff like S8 and P4. So again, these are all bonded to each other, but then we have compounds, where compounds are 2 or more different types of atoms. And here again, we can have compounds that are ionic nature, or they can be molecular in nature. So if it's ionic, it's made of ions, such as sodium chloride, salt. Molecular, made of non-metal atoms. So stuff like H2O, CH4, C2H2, all sorts of stuff. So our nonmetals. Ionic, like I said, it's made up of ions, but that's also a metal plus a nonmetal. Another way of looking at that. Okay, our ionic compounds and our molecular compounds. So, I'm just going to real quick do a quick Venn diagram of molecules versus compounds. Both molecules and compounds are composed of 2 or more atoms. To be considered either, you have to have 2 or more. With compounds, they have to be with molecules, it could be the same atom or different atoms. So we have same atoms, we have an element, and then if they're different, they're going to be a compound. Another thing that differentiates compounds from molecules is the variety. Within a molecule, it has to be 2 nonmetals, 2 or more nonmetals, so composed of only nonmetals. And with our compounds, it could be metals plus nonmetals or nonmetal plus nonmetal. So it can be ionic in nature or covalent in nature. Okay. Moving on, we're going to look at a mixture. So a mixture. No, that's not what I'm talking about yet. So let's look a little bit more at our elements on our periodic table. So our periodic table is full of elements, and when you look at our periodic table, you probably see a bunch of symbols. These symbols are 1 to 2 letters long. The first letter is always capitalized. And then the second, if there is one, is lowercase. Okay? The symbols are going to be unique to the element. And there's also going to be a unique name for each element. So each element has its own name. The thing that differentiates our elements from each other are going to be the number of protons. So each different element type has a different number of protons. We'll talk much more about protons in subsequent modules, but protons, we call that our atomic number. And that number is going to range between 1 and 118. So that is the number at the top left of your element. So we talk about element number 118, our very last element in the periodic table. That's how many protons it has, and that's the atomic number of that element. Okay, a little bit more about compounds as well. Compounds are going to have a specific composition of elements. specific or set composition of elements. So it would be a set whole number ratio. And this is the law of constant composition. So our scientific law, and it was first stated by French chemist Joseph Louis Proust. So he's the first one to come up with the idea that to be a compound, it has to have a set composition of those elements. And when we think of our compound and we compare it to the elements that make up the compound, their properties are going to be very different. So the properties of a compound varies widely varies significantly from the elements properties that make it up. For instance, if you're to think about hydrogen gas, oxygen gas, and water, H2 plus O2, hydrogen gas plus oxygen gas, combine to give us H2O, which is our water. So this is our chemical equation to take hydrogen gas and oxygen gas and form water from it. Hydrogen gas and oxygen gas, those are elemental forms of hydrogen and oxygen, and then H2O is our compound. Hydrogen and oxygen are both gases at room temperature. Water is a fairly high boiling liquid. So if we look at hydrogen, it boils at negative 253 degrees Celsius, oxygen at negative 183 degrees Celsius, but water is going to boil at a positive 100 degrees Celsius. So they're going to have very, very different physical and chemical properties. Another thing, oxygen gas and liquid water are non-flammable, while hydrogen gas is highly flammable. Okay, that concludes our pure substances. Let's move on to our mixtures. So here we have two or more pure substances mixed together in some ratio. And while our pure substances are going to have a fixed composition, right, that law of constant composition, our mixtures do not. So mixtures don't have a set composition. Okay, it just depends on how much of each of your substances you're going to add in. And when you make a mixture, there is no altering of the pure substances when you're making the mixture. So the components of the mixture are not altered during mixing. Okay, so you put them together, but your pure substances are still the same substance, so no chemical reactions are occurring. And in theory, any mixture can be broken down or separated into its pure substances using physical means. Any mixture can be separated into the composite pure substances via physical means. separation of a mixture by physical means, something like filtration or boiling off a substance, something like that. Our mixtures themselves can be heterogeneous or homogeneous in nature. So their composition. Heterogeneous or homogeneous. With a heterogeneous mixture, we're going to have a mixture where you can see the different components. With the unaided eye. As in, you don't need to use a microscope or anything like that. You can actually see the different components. You can actually be like, okay, here's one component, here's another one. And here, there is no uniformity. With our homogeneous mixture, so uniform appearance and composition. So everything will be, the components of the mixture will be evenly distributed throughout the entire mixture. Here, it's going to look as though there's only one component, so you can't see the different components of the mixture. There are two different types of homogeneous mixtures we could look at. The only one that we're going to focus on in 1211 is a solution. So a specific type of homogeneous mixture is a solution, where a solution is when we have one or more components completely dissolved or dispersed uniformly within the other component. So when we talk about something being completely dissolved, it's uniformly dispersed. Within the other component. So the components in lesser amounts are solutes. And then the component in the greatest quantity is called the solvent. A thing to note about solutions, the components of a solution are small in size. And that wraps up our talk about matter classification. Um, Hopefully, at the end of this, you guys understand the differences between our different types of matter and between compounds and molecules.